Global Positioning System developed by U.S. Department of Defense. It is worldwide scholar satellite navigation system constituted by 24 satellites. 3 of them are alternative. 24 satellites evenly distributed in 6 orbital planes. Each of orbital planes has 4 satellites. The purpose of the arrangement is to ensure that we can observe at least 4 satellites at any time and place in the world. GPS is often used as a car navigation system to be necessary guidance intersection at which corner should turn. It is often need an accuracy up to 30 meters, which is the distance between 2 parallel streets. Since GPS signal is electromagnetic waves, the message delivery is equal to light speed. As we know, the distance equal to velocity multiplied time. So when the positioning accuracy up to 30 meters, signaling time need to achieve 0.1 microseconds.
Hello everyone, now it's time for me, freshman from the Department of Physics, to demonstrate how GPS is working like. Imagine the satellite is in the space and the satellite will deliver time informational signal to your GPS device on the Earth. And once the transformation is done, we know the time interval. And as a kind of radio wave, the time informational signal is traveled at the speed of light. Then times up the speed interval and the speed of light, we can know the distance between the satellite and your GPS devices. And once we gather 3 set of data, we know accurate position on Earth. But you may be wondered that what is the relationship between this? Once again, the distance depends on interval times the speed of light, and we know as we can predict by the relativities, we know that on the satellite there is a different time from the Earth. So as my teammate stated, the time on the satellite must be modified, or we will never know the accurate position is on the Earth. That is how GPS is like, and hope you like my demonstrating. Thank you.
Hello everyone, my name is Daniel. Today I'm going to introduce the general relativity and how the theory of relativity influences our GPS satellites. The general relativity. General relativity describes that cosmic time is non-single. In simple terms, in place A and place B, the time is not equal. Of course, there are many other steps like that. And what the most influence time is gravity. Time flows faster when the gravity is weak. Second, we discuss how the theory of relativity influences our GPS satellites. The speed of the GPS satellite is about 3.8 km per second. So, from the special relativity, time on the GPS satellite is about 7 microseconds lower than the time on the ground every day. Then, we discuss the general relativity. The height of the GPS satellite is about 12,000 km far away from the surface of the Earth. From the general relativity, time on the GPS satellite is about 45 microseconds faster than the time on the ground every day. To sum up, the time on the GPS satellite is about 38 microseconds faster than the time on the ground every day. It seems 38 microseconds is very small, but if we multiply it by the speed of the light, the error will be about 10,000 kilometers every day. So we need to use a master control station on the ground to adjust the time of the GPS satellites every day. Thank you for your listening.
Hi everybody, I'm Guan Han. I want to introduce the spatial relativity-based formula. Spatial relativity has two basic formulas. First, principle of relativity. We cannot distinguish between different frames of reference from a physical law. For example, when we are in a moving car, if we don't look out the window, we cannot distinguish the car is stopped or is moving at a constant speed. Second, constancy principle. The speed of a light is always constant. In any coordinate system, the speed of a light relative to the observer is constant. It is about 300,000